Tonicity and Osmoregulation. So what is tonicity? Basically, tonicity is the ability of a cell surrounding solution to cause a cell to gain or lose water. There are three main types of this tonicity. The first one would be hypertonic. So this would mean that there would be a higher concentration of solute outside of the cell rather than inside. Also meaning that there would be a lower concentration of free water inside and a net movement out. The cell would end up looking something like this. It'd be extremely shriveled and pretty much about to die. Next we have the isotonic. This would mean that there is an equal concentration of both solute and water coming in and out, also, which would mean that there is a net movement that is equal as well. And the cell would look pretty normal, just something like this. And finally we have a hypotonic. Basically this would mean that there is a lower concentration of solute on the outside compared to the inside. So this would mean that there's a higher concentration of free water on the inside and a net movement into the cell. This would mean that the cell would be pretty much about to explode, which is not a good thing. Next we have osmoregulation. So what is osmoregulation? It is the ability for an organism to control the amount of solute that's going to be coming in as well as the amount of water coming in as well as out for both. So first we're going to look at hypotonic. So basically there is a very large amount of solute on the inside as well as a very large amount of water on the inside. And so basically the higher this difference is going to be, the more likely that the solute is going to become lysed, which basically means that it's probably going to explode. So for plant cells, this is actually called turgid, and is considered normal, strangely enough. Next we have an isotonic solution. So this is pretty much going to mean that there is an equal concentration of both solute and water coming in and out of the cell, both for animals and plants. However, for plants, this is going to be considered flaccid. It's not exactly where the plant is going to need to be, but it is good enough for it to stay alive. And finally, we have hypertonic solution. This would mean that there is a very low concentration of solute on the inside, as well as a very low amount of water on the inside of the cell. All of that would be on the outside. And this would be called a shriveled cell. And just like with the hypertonic, the larger the difference is going to be between the amount on the inside and the outside, the more likely that shriveling is going to become likely, and the more likely that the cell is probably going to die. For plant cells, it is actually called plasmolysis, or the cell is going to become plasmolysed. And the cell wall actually stays where it is, but the cell membrane starts to shrink in. So what is water potential? Water potential is the tendency of water to move by osmosis. And osmosis is the pretty much the outflow of water. And for osmosis, this tends to be that the concentration of water moves from high to low, the concentration of solute, and the water potential goes from a high to low gradient as well. Another definition of water potential would be that the potential energy of water per unit area compared to pure water. This is known as psi, and the symbol is something like that. So the way that you calculate this would be psi is equal to solute potential plus pressure potential. So solute potential, this is the symbol for solute potential, it would actually be the water flowing through osmosis. So the more solute there would be, the lower the solute potential is going to be because there is less space for water to come in. And when you calculate solute potential, it's actually pretty much always going to be negative. And then for the variables, you just plug those in as you go and calculate it through there. And then finally we have pressure potential. So pressure potential is actually going to be the physical squeezing of the cell, and the symbol is going to look something like this. So basically, pressure potential is also known as turgor potential, or turgor pressure, and it can pretty much be positive or negative, but the main point that you should take away from it is that when there is a higher pressure, there's also a greater potential energy in the system, and same way around the other way. So if there's a lower pressure, there's also going to be a lower potential energy as well. So positive pressure inside a cell is contained by the cell wall, producing turgor pressure in a plant. Turgor pressure ensures that a plant can maintain its shape, and a plant's leaves wilt when the turgor pressure decreases, but can be revived again when it is watered. Another key point for when you're calculating pressure potential is going to be that an open beaker or an open system is actually going to have a pressure potential of 0. Thank you so much, and I hope this helped.